Hello, I'm Carl Rowland with Sherline Products. This is video 2 of a 3-part series. In video 1, we just finished drilling a full-length blank, pen blank, like this guy here in the Vic Mark chuck. In this video, if you don't want to drill the full length, you can also cut your blanks to length plus a little bit, so you've got material to machine off, and then drill your through hole into a much shorter blank. This is actually probably a faster and easier way to go than the full length blank that we did in the first video. What I had done was I tore the original setup down, and I was going to move on to turning our blanks, and then I decided to do this video. So what I have are the 2 drills that I originally used, this center drill, and then this is actually shorter regular jobber length 1/4-inch drill. And I wanted to show you how to set it up real quick and easy. If you've got one of our 3 or 4 jaw self-centering chucks, the pen blank chuck, the jaws are too big to grab onto 1/4-inch round drills. So our regular 3-jaw chuck, the jaws will close down enough to actually clamp onto the drill bits. So what I've got, I have my original tool number 9 and tool number 10, and that information is already in the tool offset page. So I've already taken these off. They're not in the correct positions at all, or they're not aligned or anything. Okay, if I go to my MDI page, first tool I'm going to call up is tool number 9. I go T9, M6, and again, this is for the Masso controller. If you have Linux, you'll be calling up your tooling a little bit differently than we do on the Masso, but the general setup and procedure here is all the same. So right now for tool number 9, I'm going to tell it G90 GOO X0.0, and that moves my tool 9 to what the computer knows is 0 on my X-axis. So I'm just going to eyeball them kind of in position here, and I'm going to jog them down into the chuck. I'm going to open the chuck up a little bit and put the jog on continuous. That's into where my chuck jaws are going to be clamping on the solid shank of the number 2 center drill, sorry, number 3 center drill. And right now, with my tool post loose, I'm going to chuck onto the number 3 center drill. Spin it to make sure I'm chucked up good. Right now I'm holding my center drill right at what the computer knows is X0. So all I have to do right now is tighten down my tool holder right there. Open up my chuck jaws. Back out in the Z-axis. And without doing anything in my offset numbers at all, I just made my tool, position my tool where X0 should be for that tool. Now we'll do the same thing with tool number 10. We go into MDI, T10, M6. So it knows it has tool number 10, and then for tool number 10, I'm going to go G90, G00, X0.0, and it's going to position it where tool number 10 should be for X0. So if I'm off a little bit, I just adjust it, and again I'm going to jog it into the jaws, into the chuck. If I'm off a little bit, I can move it. I'm going to come all the way down so I can grab onto the shank. Right there's good. Again, the tool post is loose. I'm going to bring this in, clamp down lightly on it, and spin it so I know that it's clamping good on the shank of the drill. And right there, I'm going to lock down in place my tool post. I'm going to open it up and move it out in the Z. Right now, I just reset my tool where the computer already knew 0 was for both tool number 9 and number 10. If I was doing this from scratch, then what I would do is go to my tool data page, click on the drill, tool number 10, and give it a diameter of 0.0 and just click touch. And that puts that X position number in for tool number 10. So again, those numbers are already there. So right now what I'm going to do is teach my zero position, my Z0 position. For one, I'm going to be using a different chuck and my material is now shorter. So my Z offset amounts are going to change. Spin off my chuck. This is our prototype 2-jaw pen blank chuck. So I'm going to screw him on. Again, make sure your surfaces are all clean. If you have any chips or anything on the mating shoulder here, it's definitely going to cause your chuck to run out. Lock it in place. I have a saw cut on this end, which isn't square, and this end's pretty square, so I'm going to put my saw cut in first. Open my jaws up. Just close down on it, tighten it up. So that's good and tight. What I'm going to do is turn it on. I've got 300 thousandths in here. I'm going to turn it on at 300 thousandths, make sure everything looks like it's running true, nothing's loose. So that all looks good right there. Stop it. Okay, so now all I have to do is bring each of these tools up, touch the front, and teach that as 0. And I'm ready to run my shorter blank. So I'm going to go to MDI. I'm already on tool number 10. We'll leave it on tool number 10. I'm going to go to jog, continuous, and I'm just going to bring it down. Okay. If this was really critical, I would actually touch it with a feeler gauge. I'm just drilling through. I'm going to go to step mode and just step in until I'm close. Close enough. I'm going to go to my tool page. And I'm going to teach 0 for Z. So that just changed my Z offset number from my limit switch to the front of the part for that tool to that number right there. I'm going to go to jog, continuous, I'm going to jog out of it. MDI, and I'm going to call it tool number 9 again. T9, M6, so it knows it has tool number 9. Now I'm going to tell it G90, G00, X 0.0. That moves tool number 9 to X0 on the part. Now I'm just going to go back to jog again, and I'm going to jog up until it looks like I'm touching. When I get close, I stop, put it in single mode, or step mode rather. Close enough there. I'm going to go to tool number 9, and I'm just going to click on 0 for Z-axis. And now tool number 9 is set for 0 at the front of the part. I'm going to jog out of here. Continuous. Advantages to doing a shorter piece. Number 1, you can use our smaller lathe. You don't have to use our larger lathe to do this. Number 2, you can use standard jobber length tool bits because the flute length on this is longer than the length of my part. The other one is when you drill, the first peck is 3.5 times the diameter of the drill. Second one is 1.25. Third and everyone after that is 1.1. So in a short period of time, I can drill through this length stock right here, whereas this length stock, after about this much, I'm drilling 250 deep all the way through. It takes a lot longer to drill through this. The material gets hotter, the drill gets hotter. This would actually be my preferred method of doing this. And you already know basically what the length of your stock is going to be for the barrel section on your pen anyhow. So cut it and make your life a little bit easier. So right now I'm just going to call up my program. And we'll drill this guy. right. And I'm going to put it on a single block to start, just to make sure. Take it off single block. Okay. If I had set this up as I just did, and I had several of these, I'd drill them all. When I get done with it, the next operation would probably be a facing operation, in which case I could just take my drills off of here, or one of my drills off of here, and mount a turning tool in it. This is a carbide turning tool insert. You can use carbide, high-speed steel, whatever you want to use. High-speed steel works perfectly fine. This just happens to be what I had available right now. And you can either do a short program that comes from, you want to measure your diameter across the corners of your part and add a little bit to it. It would be an easy facing diameter, come over 1.1, 1.2, and just face your part off, or you can come in here and jog it. So first I'm going to make sure my tool goes past center, which it does, without hitting the limit switch. Right there, I'm pretty close. Okay, I'm going to go to MDI. I'm going to turn the spindle on. Now I'm going to go into jog. Hold on a second. Jog. Step mode. I'm at 10 thou. Right there is pretty close. 1 thou per click. Okay, I've got touch right there. Continuous. Put it down to 10%. Okay. Turn off my spindle. Change my RPMs to say 1500. Turn it on. Jog. I'm going to go in 5 thousandths. And I'm going to go to continuous. Face off 5 thousandths. Stop my spindle. I've almost got to clean up a little bit more. Turn it back on. Jog. Step. Go 4 thousandths. got a full cleanup right there. All right, this side is a saw cut side, and this side is definitely not square, so this would take a little bit more to do. You're going to want to measure it so you can bring it to size. So this is using jog. Going to turn it on again. Turn on my jog feed. Okay, so I've got a cut right there. Okay. Step mode, 10,000ths. Okay, the other way you can do this is, like I said, a short program. Okay, I can go into Mdi mode. Okay, my tool is on this side of the part. In Mdi for moving in directions, this is a plus direction, this is a minus direction. In the program, it would be minus towards the middle and plus away from the part. So I'm going to go G91, G01, X. We're at 1.2, 1.3, so I'm going to say 0.800, F2.0. If I turn it off right now, I can see if I cleaned up or not. And I've got almost a cleanup there. I'll clean up on half of it. I'm going to turn it on again. Go into Mdi mode. Z minus 0.004. I just moved in 4. Now I'm going to pull it back out. So G91, G01, X minus 0.9, F2.0. All right, so we keep doing that until we get to the proper length. Once you have it set up, go to jog. Once you have your length set, then you can shift your cutter out 20 thousandths or whatever you want. I would say 20 thousandths at least. Set up all your parts, bring them in, buzz them off on one side, flip them over, bring it into your correct overall length, and face it off on that side. So you just went from drilling to facing off your part. Okay, so our blanks are drilled and faced to size. Next video, we'll put them on the mandrel and we will turn some shapes on these. Thank you.